Okay, this lecture is going to be a little bit more bootleg than the ones from last week, just because there's a pretty big snowstorm happening, so I couldn't make it to my work to record this. So I'm doing it at home, but we are going to make it through, I promise. So in this lecture, we're going to focus on two different styles of 3D drawing techniques. We're going to cover 3 different styles in this course. So next week we're going to focus on the last style, which is perspective, but in this one we're going to focus on isometrics and obliques. And isometrics are considered part of the axonometric drawing family. So the purpose of 3-dimensional drawings is to help understand the object as like a comprehensive whole and how different parts or pieces come together. So last week we discussed orthographics, which breaks an object down into its 2-dimensional faces. And then we'll often pair in a set of drawings, we'll pair that orthographic with an isometric or with an oblique, just to kind of see what it's going to look like as an end result. Because oftentimes those 2-dimensional faces or section views can become a little harder to understand. So having the 2D orthographic paired with a 3D isometric or a 3-dimensional oblique then helps us fully comprehend what that drawing is going to, or what that object rather, is going to look like in the end result. So last week we discussed that all objects have 3 dimensions, and those dimensions are width, height, and depth. And those all then are projected onto 2-dimensional planes for our orthographic. And those planes can be broken down based on 3 different axes. So we have here on our x-axis, this would be our width, our y-axis would be our height, and our z-axis would be our depth. So any of you here who are familiar with this really niche indie game called Minecraft, you're probably also very familiar with coordinates and your x, y, and z axis. One thing to keep in mind though, in some modeling softwares, the z axis label and the y axis label can be interchanged. So in a lot of 3D modeling software, height will be described on the z and depth will be described on the y. So that's not really going to throw us off too much here, but just to kind of keep that in mind. Now, when it comes to those different faces, like the front face here is sitting on the XY plane. So that's this blue plane here. So this frontal plane can tell us things related to width and related to height. But again, the XY would have nothing to do with depth. Then our top view is going on what we often call the horizontal plane, because it's lying flat horizontally, looking straight down. And then this can tell us related to width and depth. But remember that top view, those plan views can tell us nothing about height. And then our side view is coming from what's called the profile plane, which is the green one here. And that can tell us depth and height, but nothing related to width. And again, in architecture, our plan views are going to come from this horizontal plane, this red one here. And then our elevations, our sections are going to come from the frontal plane, this blue one, and then the green plane, the profile plane, depending on just how you have it oriented related to the building. Now, when it comes to a 3-dimensional style drawing, we are going to draw with all 3 of these axes in mind. So instead of just only using 2, we're going to use all 3 of them. That's why it's a 3-dimensional drawing. Now, an important part to keep in mind whenever we are drawing something 3-dimensionally is to think about what the end result is going to look like, and the easiest way to approach it is to break it down from kind of an original drawing or an original object. So I consider this to be the subtractive method, in which I always start off my object with an overall bounding box and then subtract or cut my piece out of it. And I described the same method and showed it with the orthographics, where I just start by saying what's my overall width, what's my overall height, and then I'll just kind of carve my front face out of that. I'll do the same thing with a three-dimensional style drawing, where I just make a big box for a 3D drawing that says what's my overall length or width, what's my overall height, what's my overall depth, and I'll make like a rectangular prism or a cube or a cylinder based off of those overall measurements, and then start to measure how far back a slanted face might go and then how far down, and kind of cut that out. So that's what's being shown here in this drawing, rather than try to figure out what this angle is going to be at, because based on the three-dimensional technique, that angle is going to change. Same thing here for this end result. Object is to figure out where this little cutout's going. We're measuring how far back and then how far down it is, and then we can just kind of lay it out in there. So instead of trying to just start from scratch making an object like this, we're just going to start with a basic box or basic bounding box and then carve the part or piece out. Now, the most common style of three-dimensional drawing, particularly in manufacturing, is called an isometric. With an isometric style drawing, you are having equal emphasis to the three main faces or planes of the object. So your front view, your top view, and your side view are all getting equal emphasis in that object. So we have here just kind of a little Lego block made where this is my top, this is my front, and my side, and all of them are having an equal emphasis to each face. Now, since this would be my z-axis, my x, and my y, we can define it based on the angles between those three axes, and that angle is going to be 120 for all three of them. So the angle between this z and this x right here, this angle is 120. Between the y and the x, this angle here is 120, and then this angle here is 120. So that's one way you can think of it. The way I'll typically think of an isometric is that we're projecting back at 30 degrees. So if there was a horizontal line right here running flat across this point, this is going to be 30 degrees and this is going to be 30 degrees. And that's why often if we're doing a technical drawing using all of our different sets of tools, we would use a 30-60 triangle to draw in those lines. Parallel lines are still an incredibly important concept in isometric drawings and in obliques as well. And what we mean by parallel, of course, is that our lines are staying the same distance apart no matter what. So this line here is parallel to this line here, is parallel to this one here, parallel, parallel, parallel. Same thing then on this side face, all of our lines are parallel, and all of our vertical lines are also parallel to each other. So any line that's sitting on the plane is going to sit parallel to the next line that it is also describing. If I have objects that are circular or have curves in them in an isometric, they are going to appear as what we call an ellipse. Now, for an ellipse shape, what I always do drawing is I start my object overall again with just a bounding box, and then through that box I can pinpoint where the four quadrants are. So that would be the north, south, east, and west of the circle, and I then can trace out my ellipse. So then that method works whether I'm doing an object and it is sitting on a perfect square face versus if it's on more of an elongated rectangle like this. I can just trace it out to make sure I'm hitting the 4 points, and then I can either keep the entire ellipse if that's what I need, or I can just kind of carve out the different curves that I might need for it based on the object. And we'll take a look at that when I do some hand drawing demos in a moment. Isometrics are also super duper handy for creating exploded assemblies of objects. So we'll see them in manuals of just assemblies for different parts or pieces. Not incredibly a lot for architecture, though we will see them for like steel structures quite a bit in architecture, of just understanding how the building is going to be coming together. Now, an oblique drawing has a lot of the same concepts as an isometric, but with an oblique, we have an emphasis to a particular face. Now, there's two main styles of obliques when it comes to architecture, and that is a plan oblique and an elevation oblique. And really what the difference is going to be depending on which one of the faces, the top or the front, is going to include 90-degree angles. So we have right here, here, and here. And excuse me if my mic's making noise, but I have a cat slapping its tail right next to the microphone. But these three are all elevation obliques versus this here is a plan oblique. So an oblique view is drawn with one face head on, just like we would describe it with an orthographic. And then we project back at an angle. That angle could be 45 degrees, it could be 30, it could be 60. The angle is not really going to be essential, like necessary to defining it as an oblique. The important part of that angle is that you're consistent with it. So if I'm projecting back at 45 degrees here, I'm keeping all of my lines parallel. So I'm projecting back at 45 degrees, projecting back at 45 degrees. Here we have 45, 45, 45, 45, 45, and you guessed it, 45. So all of these lines are being projected at 45 degrees, describing the depth, but that front face is head on. So in an elevation oblique, the front face contains 90-degree angles. So we've got our 90, 90, 90, 90. We've got 90-degree angles here, and same thing on this one. We've got our 90-degree angles are available on our front face, but then on our side face, this would be, I guess, 135, and that would also be 135, because all three of those would have to add up to 360 degrees. So just kind of keep that in mind, that the front face has that 90-degree angle. On a plan style elevation, the top view has 90-degree angles. So we see here in the top, we're at 90 degrees, 90 degrees, 90, 90. But then our side view is projected at an angle, and so would be what our front view is projected at an angle. So with a plan oblique, you have that front view consisting of 90-degree angles. It is, however, kind of oriented on that tilt, which I think throws some students off. And then with the elevation oblique, it's at that 90-degree angle in the front. So what we are going to do for you now, for me just a moment, because I'm going to make a cup of coffee before I do it. But I'm just going to test out some three-dimensional drawings for you with the hand camera, so you can see what these different shapes here in the presentation look like as isometrics, plan obliques, and elevation obliques. Now, you do not have to follow along with me like we did with the practices in class. You don't have to follow along, but if you would like to, feel free to grab some paper, and I'll see you in just a moment. Okay, so now we're going to start drawing this or these objects out in some different three-dimensional styles. So I am going to, again, go a little rogue, so I'm not going to do this traditionally the way like a super specific set of plans need to get hand drawn, just because that's not really a skill that we need. We need to know a little bit more of just how to freehand sketch it. So I do just have a sheet of tracing paper here. I don't even have it taped down, which if you want to tape it down just because you don't trust yourself keeping your lines super parallel without it, that's totally fine and totally okay to do. But I am just going to keep mine a little bit looser. and I've just got a little mat underneath it to draw on, because I'm not going to be able to use graph paper like we did last time to help keep our lines parallel and perpendicular, because we're not just keeping our lines horizontal and vertical like we did last time, because now we're going to be going at specific angles. So I cannot use graph paper to just help me keep my lines straight across, straight vertical. If I wanted to get extra fancy and purchase some stuff to help me do so, you can buy, and I don't know how well it's going to appear on the camera. Well, you can kind of see it. This thing has a light built into it too, I'm pretty sure. Whoa. Oh no. There we go. I don't know if that light helped or did anything. But pretty much this is just isometric graph paper. So it's got a little graph on it that's going at that isometric angle of 30 degrees. So if I then wanted to build up my object on an isometric box, I could do it. And again, I'm just quickly spitting lines out. So none of these are exactly precise. But I can quickly put together an isometric prism with relative ease, just because it already has that 30-degree lines. I honestly couldn't tell you how expensive this is, because I've never personally purchased it. I have only just ever use the stuff that the school has bought. The other thing you could definitely do too is just go online and find like an isometric grid, print that out on a single sheet, and then put that underneath your tracing paper as just a guideline if it's something you wanted to do because you want really, really nice, perfect isometric lines. But I'm just going to do the dangerous thing called eyeballing my isometric lines. And in some occasions too, I'm going to use this tool, which is a really nifty, handy tool that I love, just to keep my lines parallel. So if I have a single line on my drawing, pretty much what I can do is just line up my tool here with it, and then I can just project parallel lines off of it without having to worry about taping things. And even if then I had like a line there and I just wanted to keep lines parallel, is I could line that up and I'm getting two lines that are parallel to each other, because this is just helping project it but at that same angle. Really cool tool, kind of hard to find. You can find it online pretty easily if you go to like marine supply websites or mapping websites. So this one comes from Weems and Plath. But probably a little pricey too, if I'm honest. But I love it, and as someone who does a lot of hand drawing stuff, worth it. Enough about random supplies and tools. Let's get into breaking this object in the corner down as an isometric and then as the two different oblique styles. So it's already drawn as an orthographic, and we're going to break it down into its front, top, and, or excuse me, it's already broken down as the ortho, so it's already in its front, top, and right side faces. And so we're going to just make sure then that we are kind of bringing it back into a 3D style view. So I'm going to just start by creating an overall bounding box of just what the overall length and the overall width, depth, overall height is. So I'm going to start with just saying the height is about that tall. And again, I'm not using any particular measurements for these. If you wanted to break out a ruler and measure them, you're more than welcome to. And I'm going to go project back for my depth and over for my width at an angle of 30 degrees. And so please stop auto-focusing on anything here too. Uh-oh, here comes a cat. So if this is 90 degrees, 45 degrees would be directly in half, and 30 degrees is a little bit underneath it. The more you practice, the better you are going to get at like eyeballing what 30 degrees is. But there's not much else I can tell you other than that it's a little bit less than halfway, and that the more you eyeball it, the better you're going to get at it. So I can eyeball 30 degrees pretty well. Don't know how helpful that is for you. And then again, I want to make sure I'm keeping lines parallel with each other. So I'm just going to try to keep that same consistent angle. And again, while I'm drawing, I'm not moving my wrist around. I'm just moving my hand back and forth. And that even then helps me really keep that angle at the same amount too, is that if I'm just going over it, keeping my lines parallel. So I kind of get like this little rhombus or rhomboid shape. And then I'm going to just make the rest of the box for the front. So it's much longer for the width on that front side. And so I've got an isometric style cube or style prism. It's not exactly perfect for the angle, but it's getting the point across for this particular object. And now it has in this front face, it's got that little slot sitting in it. And so I've got my overall bounding box, and I'm going to carve out where that slot goes. So it's about this far over on this side, that far over, inward on that side. Again, I'm just kind of generalizing measurements and making some estimations just based on proportions. And so I'm just going to project those straight down and then project that bottom face of the slot at a 30-degree angle. So again, I'm just trying to keep it parallel with all of these faces here. And then project the edge back, again, keeping everything parallel. Once my back edge reaches here, this slot does travel all the way through the object, and I can tell that because in the front view, there is no back edge for it. So we'll just project that line down onto that edge back. And then again, a lot of times I won't erase guides. In this case I will, because I feel like those guides kind of make it a bit more confusing for what this object is. And so here is this little kind of slotted object as an isometric. Now for a elevation oblique, with that style, we are going to start by drawing the front face head on, just as it appears in the orthographic. So for an elevation oblique, we're pretty much just mimicking what we see in that front face. Using some of those same sketching techniques that we discussed last week of just, putting light lines down and then building them up, tracing your line a couple of times before committing to it, and then again looking at where you want your drawing to, or your line to end, instead of looking at it as it travels. That just will help you kind of keep the lines a little bit straighter. And I am aware that I made this a little bit shorter than like it actually appears in the ortho or than how I drew it here. But for the concept of what an oblique is, that's what's important, not necessarily that I got my measurement beautifully, perfectly right. And so I've got my front face head on. and I'm going to project back at an angle. And remember, you could do that angle at whatever you want it to be. In the examples in the presentation, that angle's 45, but we just need to make sure we're being consistent so that that angle stays parallel. So I'm going to project back, project back, project back, project back. I'm just trying to make sure I'm keeping my lines parallel. And then once I have that depth established, oftentimes what I'll just do is measure the depth on just one of those edges, and then I can just project up and straight over. So then here is the exact same object, but as an elevation oblique. So with this one, we're getting major emphasis on that front face and any features that might be sitting on that front face. We also get to see some details on the top and the side, but the top and side are getting a little bit distorted when it comes to that particular view. And so it's really going to be reserved for if there's a particular face that I need to show more detail to. Now, the plan oblique, as I mentioned, tends to get students the most confused. Let me just sharpen my pencil. Oh, sorry. I scared a cat. So sorry. So again, with that plan oblique, what I'll often start with is starting by drawing the top of the object in a bounding box on whatever angle I want to kind of have it tilted on, purely because this is going to help me relate it back to those 45-degree lines. So if I start with drawing the plan or the top of it and then project down, or even then I could also project wells up if I needed to, but that's going to help me just orient it and make sure that I'm keeping my 90-degree lines here, as opposed to in this view I've got my 90-degree lines here in my front. And then I'm just going to project straight down, project straight down, project straight down, and we're going to have the important factor of, again, keeping lines parallel. So whatever angle I used here, I'm just going to follow through with the same angle here. I'm going to say that's about 45, but again, I didn't measure it, and I don't have a protractor, so. But I'm just kind of tracing over that line, so that way I could easily just move my arm in the same position, just kind of get it to be about the same. Let me just get rid of some of this because I went a little bit too far down. One thing also I love about tracing paper is really easy to erase on. So now that I've got that overall bounding box, maybe that angle isn't perfect for it, but you know what? It'll get the job done. I'm then again just going to start measuring out of carving where that little slot is on the front and project it down. Keep my lines parallel. Keep it parallel, which maybe I didn't have my proportions perfect, but again, for this concept, I'm not incredibly worried. And so then this is that object up in the corner. That's the object as an orthographic, and then we have it as an isometric. So with an isometric, you're getting the least amount of distortion. You're getting equal emphasis to all of the faces. So the angle here is the same as the angle here, is the same as the angle here. So all of those are getting an equal share. versus an elevation oblique. I was going to say front elevation. So in this we have a 90-degree angle and then 135 and 135 versus then the plan oblique, which in here we have our 90-degree angle and then our 135 for it. So now I'm going to hit pause, get a fresh sheet, and we'll do the next one. Okay, so this next one is this little kind of funky Z-shaped guy. Let's keep that. I'm actually going to tape it down this time just because since this was fresh off the roll, it's got that curve to it, and I don't like that. So I'm actually going to tape this one down, and I don't mind since this board can move freely. Because as you might have noticed, when I'm doing 3D drawings, I do like to move my drawing more rather than try to move myself. And these are those drafting dots that I don't recommend you purchase because I think they're a waste of money, but the school bought a bunch of them, and so I'd rather use them and then just tell them, hey, don't ever buy them again, rather than have them and then not use them. I think that's an even bigger waste of money, but I digress. So again, we're going to start off this time with an isometric, and then we'll do our two different style obliques. So I'm still going to start by just drawing an overall bounding box of my shape, starting off with what I want kind of my front corner to be, and then projecting at 30 degrees, keeping these as parallel as possible. And it does take practice to be able to kind of eyeball angles and keeping them parallel. But that's kind of what this class is about. And then for the next one, when I pause, I'll actually go get a 30-60 triangle. I'm sure I have one somewhere in this apartment. So you can see kind of what that looks like and how you can use those tools. But I just have my overall bounding box. And again, I'm just going to start carving out the different features here on this front face. So it's got this little Z kind of cutout that's here that goes about that far in, and then straight down. Maybe I should have made this front face longer. And then we've got this one here that is about a third of the way up and goes in a little bit. Yeah, I should have made this longer, but it's okay. And then it comes straight up here. And then I'm just going to project these edges back. Now, the nifty thing with isometrics is that also you can kind of project lines to meet each other. So I don't know necessarily how far back this edge goes here on like my bounding box cube. But what I do know is that it's going to just come to meet this vertical line that comes straight down. And this line then that comes straight over to meet it. So all of these lines are still going to be parallel to each other here in this isometric. And then I can get rid of my bounding box. And again, if you do your guidelines light enough, you don't have to go erase a bounding box. But I do my guidelines pretty dark just to make sure that they're going to appear on the camera. Now, we're not going to have any hidden lines for things like this edge that comes back here, and then this edge that goes back this way, and this edge, like those are not going to exist as hidden lines purely because in an isometric, that's going to be far too much information. It's going to make the drawing more complex. So we do not include hidden lines for different hidden features in an isometric or an oblique, and especially then in a perspective, because a perspective is really made to show the object as like a realistic rendering, and we do not want or need that. So now the same object again, but as an elevation oblique. So we're going to start with our front face head on. So I'm just going to draw, and I can do this still as an overall bounding box. I know I didn't do that last time, but I'll do it this time. Where I'm just going to draw the front face of my object, project back at an angle. And I often use 45 degrees, which is what I'm aiming for with this particular angle. But again, it's just really keeping that angle parallel and consistent. Hopefully I've said that enough times for it to have sunk in. And especially hopefully I've showed it that you understand what I mean when I say parallel and consistent, that this angle here is the same one as here. And that this vertical line here is at the same angle as this one. And I'm just trying to keep them as straight as possible. So I've got my overall bounding box of it. Another way too that you can think of elevation obliques is if in school you ever made a cube like this when you were in like middle school, and then you connected all of them. That's an elevation oblique. You just didn't know that's what it was called because you were in like 6th or 7th grade. Maybe, I don't know when they do that nowadays. That was me. Maybe not. Maybe I'm just showing my age now. Anywho. So again, I'm just going to start carving out my different features. So I've got this little ledge here. That's about 1/3 of the way down. And about that far in, maybe less. Again, I'm just estimating. And it goes straight down. And then we've got this one here. That's about that far up. About that far in. And it goes straight up. And then we're going to project these edges back at that parallel angle. And for this line, I'm just estimating how far back I think it's going to go. I can take a reference from here too of just like, well, it's going to go to meet that one because this edge just travels all the way back for this object. And then that would go straight down to meet it. And so this would be the same object, but as a elevation oblique versus a asymmetric. And then as a plan oblique, again, I'm going to start by drawing my overall bounding box. So I'm going to start with my top view. I usually always start too big whenever I do elevation obliques. Or plan obliques, excuse me. So I'm going to do the plan oblique up here too, so that way I don't run out of space again, like I seem to be doing. So I'm just drawing out my shape here so that I'm getting those 90-degree angles between these two lines. And then I'm going to project straight down. And it's going to come off my page a little bit, but you can actually see, so perfect. I'm just drawing this piece of chipboard And so I've got my overall bounding box, and then I could start carving out my shape. So about that far up. And I'm going to try to keep it consistent with that angle, keep it parallel. And then we've got this feature about that far down. Again, keep it consistent for the angle. And I've got my little Z shape here. I'm going to project back. And then I've got the shape drawn as a plan oblique. Now, a lot of times I'll get asked, why have the different style drawings if the elevation oblique and the plan oblique are kind of harder to draw, and then they tend to distort the object quite a bit? Like, why even have this as an option or this as an option if this is giving equal emphasis and it's a little bit easier to approach? And so this is used if there are things on the front of the object that I really want to give emphasis to, I really want to show. And then I also just want to remind the viewer or the person who's interpreting the drawing to make a product that, oh yeah, and it has depth that's going all the way through. And then this is if I wanted to have emphasis to the top of it. So particularly this is going to be used in architecture a bit more to really help show kind of like a floor plan layout of a building for a concept that's being bitted out. And so I've got my isometric, elevation, and plan oblique all for this one singular object. And again, I'll hit pause and be back in a millisecond for you guys for the last one. Okay, whoops, I forgot to change the picture. One moment. There we go. So for this last one, I thought what could be interesting to also just go along with showing you how these tools work. So these are set squares. This is a 45. This is a 3060. They are little tiny ones just because I just like the tiny ones. I don't know why. Honestly, they're kind of inconvenient, but it's just what I like. I think they're cute. Why someone might want to use tools like a T-square and everything to set drawings up. So figured I could do that. So I do have here on my little drawing board, I'll move the camera over so you can kind of see it. So I've got my T-square hooked on the side of my drawing board, and I'll just do this one as if it was a super precise drawing. But again, I'm not going to use measurements just because I don't feel like counting boxes. So if I was using all of my super technical stuff, the first thing I'd be doing is taping my paper down nice and straight. So I'm just aligning it with the edge of my T-square and taping down all of my corners. Oh, I thought we were going to get a visit from a cat, but he just walked by. What a shame. And so taping the corners down is it ensures that as I move my tools around, all of my lines are going to stay nice and parallel to each other. I would use this to draw any horizontal lines that I might need to draw, and I would use my tools here to draw any vertical lines. So I would take this and kind of sandwich it against the T-square, and I'm always kind of pushing the T-square against the board. So as I'm holding it in my hand, I'm kind of pushing it a little bit this way to keep it against it. And I'll just start off by drawing the axes for my isometric box. And so I'm going to use this one to just project at 30 degrees this way, flip it around to go 30 degrees this way, and then straight up. And so the purpose of these tools, again, is like I don't have to worry about second guessing if my lines are going to be parallel to each other, because the tool is going to take care of it for me. My box that I'm making here is going to go off my page, but my final drawing shouldn't, so that's kind of the good news. But with this, yeah, my drawing actually, this is all going to go really off the page. You know what? If I'm going to be precise, I'm going to do it right. We're going to start it lower. Sorry. So I'm going to start it here. I'm going to go 30 degrees in that direction. You can also flip it over that way. 30 degrees in that direction. 30 degrees. And so this is that exact same bounding box concept. Oh, look, I'm still going to go off the page. It's okay. It's much better than last time. So this is that same isometric bounding box that I did here, but I don't have to worry about, did I make that angle at 30? Because if I have this flush against the T-square, I know that my angle is going at 30 degrees, but I just have my overall bounding box. Now I'm just going to start to flesh out some of the details for that front face. So it has, this is kind of like a salt box style roof. I've got this ridge right about here on it. And that just travels all the way back. So that's going to stay at that consistent 30 degrees. And then travels to about here on this side of the front, and then about there on that side. So these are what we would call non-isometric lines because they're not sitting directly at 30. But what we can do is just take some form of straight edge and connect them. And so again, that's why the bounding box method can be super duper helpful, because I don't know what that angle is going to be in this isometric drawing, but with the bounding box, I can just hold them together, bring that edge straight back, connect these two, bring this edge straight back, and that corner up here off the page straight down, and then that would tell me where these two are connected. And it's also then going to just be that this is a line parallel to this one. So I then can get rid of my bounding box that went off the page, and since I'm on just regular bond paper, just like sheet paper from a printer, it's a little harder to erase my guides since I went so hard with them. But I figured it'd be better than tracing paper. And I don't like tracing paper alone on a drafting board. I like to have something behind it, like a piece of chipboard, because I just think it's too delicate and too dainty, and I guess I'm a little rough on my paper. So this is my house, my little house box as an isometric style. Now for an oblique, I'm going to start it off here. I'll do the plan oblique first so that this way I don't run out of room in the bottom. And this time I'm going to use a 45 triangle, so I'm still going to keep it flush against my T-square. I'm kind of pushing my T-square against the side of my board and then pushing down with the triangle. Again, if you don't have tools like this, that's totally fine. You don't need them in order to be able to do the drawing. You can still continue just with those freehand techniques. But I just wanted to show you how some of these work and why you might want to purchase them. So I'm going to just start by drawing my front or my top. And already I think I'm starting too high on the page. Need to trust myself more. And since I'm doing this all with a 45-degree angle, I'm just going to do the entire top here at 45. If all of these lines are projected at 45, then all of these are going to be giving me right angles. And then I'll just slide my T-square down, but I'm still pushing it up against the board. Project down, project down, project down. So again, I'm just starting off with an overall bounding box for my object. And I can just get cleaner lines way faster if I'm using tools like this. So again, now I'm going to just start carving out some of those features. So like I know that that ridge is about here. It's pretty much halfway through. And then I've got this front face or this front edge here. And then this back one is about that far up. So I'm just kind of marking out where different parts or different features are. And then I can just use some form of straight edge to connect the dots. So this particular shape is not something I would ever recommend doing as a plan oblique. A plan oblique is usually used for like if we have like a building cut open and we're looking at the floor plan, that's where that plan comes from. This shape is going to look really weird and distorted as a plan oblique, but part of why I wanted to do it as an example was to show how obliques can distort things and make them look a little bit weird and a little bit different, because here in this plan oblique, this kind of dramatic salt box pitch of it being shorter in the front, higher in the back, is almost not even really all of that visible in this plan style oblique. It looks almost like it's just a regular gable style roof from a plan oblique. Now with the elevation oblique, again, we're just going to start with an overall bounding box. And the front is going to be head on. So I'm going to use my T-square to draw that horizontal line. Again, I'm still pushing it against the side of the board. And when I use my triangle, I'm pushing it against the T-square. So I'm kind of pinching the two of them together. Projecting back at an angle and keeping those angles parallel. Whoop. Making sure I'm actually holding this against the board. And then once I have a depth established, just making an overall box. Again, something I've been told before is like, well, how do you estimate these lines to meet each other so well to do less erasing? Practice of just knowing, oh, that's where that line's going to end up. So I could have just made this line way longer, made the two of them meet, and then go back and erase it. But again, after so many years, it'll just start to become kind of second nature to you. So if your lines are not meeting right away, do not feel bad, because when I first started out, my lines did not meet any either. But now I'm just going to draw the front face here on my elevation oblique, just as it appears on the orthographic. So I'll go about want to say that's like 2/3 of the ways up here. So we'll make it a little bit higher even. And then further down here, about halfway at that ridge. And then since these lines are not, they're called non-isometric lines, we're just going to connect the dots. Connect the dots. And then once we've got those established, we can project back, project back, project back. And this one is just going to go back to meet where that corner is. And then again, we've got non-isometric lines that we're going to connect and connect. So where did I throw my eraser? There it is. And so now I have a elevation oblique of that same object. So again, it's the same object just from three different three-dimensional perspectives. An isometric where all of them are getting the equal emphasis. A plan oblique where it's emphasized to the top. However, in this shape where we have such an asymmetrical top, would not really be recommended as a perspective type. And then a plan or an elevation oblique. For this particular object, I would do something like most likely an isometric, because still in the elevation oblique, we're getting a little bit of distortion here with like this particular slope. Which is making me even question if I did that at 45. I sure did, but it almost doesn't look like it just because of how distorted it is. And so here would be these three objects in the three different styles of drawing. Before I go back to the presentation board, just to kind of again relate these to architecture, just to kind of show you some other examples of the same style drawings related to sketching that some of my other students did in my capstone high school course. So these are students who have taken about like 3 or 4 drafting courses, and so we're just doing some sketching reviews in the first week of school, and so they've just taken some objects from around the classroom. So here is just a marker drawn with a orthographic of it from each side, and then an isometric. He did a good job with this isometric though. What I would definitely recommend, and what we talked about in our little sketching critique, is to try to do this top of it based off of an ellipse. And what I mean by that is drawing kind of the face as if it was just a square, and then hitting the 4 corners. So trying to break it down into a little bit more of an ellipse shape, but it is kind of a difficult shape to do that with, but since it is also curved there. Would you like to say hello to the camera, Cat? Oh, he would like to say hello. Turn around, say hi. You are perfect and precious. This is Millhouse, guys. He's my favorite baby boy on the entire planet. Then this is also another one that a student did of a pencil sharpener. Hopefully that's pretty obvious of what they did. And so again, breaking it down into its front, its top, its side. And then since it does have that kind of curve or that angled line going towards the bottom in the isometric, it is going to not necessarily appear on that 30-degree angle that's approaching. But he also did a fantastic job. And then another one here of a case for a set of headphones. So she did her orthographics here. First starting it off, the guidelines she erased pretty well. So you can kind of see how it did start off with an overall bounding box on each of these, and then just sketched into the curves. And then the same thing with the isometric drawing of it just starting with an overall bounding box and then working out where the curves are going to go just using a sketching technique. So she also did a really good job. Now, how a lot of this relates to architecture is through exploded assemblies of buildings and drawings. And so if I ever needed to hand draw an exploded assembly of a building, so if I needed to kind of show how the walls, and let me actually maybe get this up so it's not in our way. But if I needed to show kind of how a roof is sitting on top of the building and how the walls kind of insert into it, and then even break it down further into, you know, how the windows and the doors are getting inserted into it, I always start these style isometrics, these exploded isometrics, as just one cohesive three-dimensional building. So I'll just draw it, and I've got two examples here just done on that isometric graph paper, but it's pretty much the same building where I have everything condensed, started off with, and you can see a little bit of the guidelines here of just that overall bounding box, and then I can work out like where the slope of the roof for the building goes, how thick the roof is, where my windows and doors are placed, but everything is still lying on that axis there. Because once I have the overall building made, then I can take something such as tracing paper and I can lay it on top of the overall building and get my building sketch, remove my tracing paper, lay it then on top of just the roof, get the roof part, because otherwise getting this final result with that perfect sloped roof for the angle is going to be really difficult to do, because I need to calculate what that roof slope is and then calculate the angle of it in an isometric view, which is just really difficult to do. So instead I'll just have everything mapped out, laid out here, and then I can just move my tracing paper along to make my building, untape my tracing paper, trace out my wall, untape my tracing paper, trace out my windows and my door, untape my tracing paper, trace out where my stairs are going, and each piece individually if I ever needed to do an exploded view. And even then, if my exploded view starts to get really kind of messy looking or sloppy, then I can go over it a final time, which I had, there it is. So then, you know, if I have this exploded view and it looks a little sloppy, I can always just take another sheet and trace over it exactly as is, and then have a nice finished clean version to go, which is why I also love tracing paper and vellum. That's another thing too that I believe I mentioned in the first video, which, let me get some, sorry. I'm sitting on my ground right now with just a lot of supplies around me. But yeah, I believe I mentioned it in the first video. So this is vellum. It's like tracing paper in that it is see-through, but it has kind of a plasticky consistency, so it's much nicer to draw finished products on, because tracing paper can kind of get wrinkly. I don't mind tracing paper a whole lot because of that. In fact, to me, it takes the pressure off making a nice drawing. But that's just kind of how these isometric and oblique style views can be related to architecture. Additionally, so we can see here some examples of the Eames residence, which we saw also some pictures for the architecture stuff in our last presentation. So this is still that Eames building, but here it is as an exploded isometric. So we're getting equal emphasis to all of these views. versus it as an exploded plan oblique, excuse me. So within here, we have our 90-degree angle. We're focusing on the floor plan, but we're still projecting three-dimensionally. So with that, your assignment for your oblique styles, or rather your three-dimensional styles, is, I thought I had it open. I didn't have it open. It's okay. We'll make it bigger. Is, again, you're going to need some graph paper and or tracing paper. You can use regular bond paper or printer paper if you'd like. You'll need a pencil, an eraser, some tape, but tape honestly can be optional, and a straight edge technically can even be optional. And for this one, you are going to select a chair on campus or at your house, and you are going to draw it three-dimensionally. It can be any style of the chair from any location or any view, so you can decide kind of how you're going to approach it from three-dimensionally, whether it's from the front, the side, or behind. I would recommend starting on a sheet of graph paper to help keep your lines parallel, and then tracing over it onto tracing paper. So this might be, like I showed with those house drawings, something that you have to kind of sketch out multiple times, where you first started off on graph paper and then do a final clean drawing on your tracing paper of vellum. You are going to do the exact same chair as an isometric, a plan oblique, and an elevation oblique. And you're going to do this using estimations to keep it proportional. So for this, I would recommend starting off again with those basic forms of starting off with creating an overall bounding box of the overall height, width, and depth of the chair, and then breaking it down into each one's. Same thing, similar to those examples I showed of my students' work from like their pens and pencil sharpener and headphone case, is they started off with just basic blocks and then built their drawings out from it. For extra credit with this drawing or with this assignment, you then can research shading and sketching techniques. You can also find those in your Yi text and the Ching text, but you can find examples as well online. And you are going to add shading techniques to them, and then you can also create a fabric or material kind of mood board for the object to kind of help further sell it or describe it. If you have any questions about this assignment, feel free to let me know, and you can choose your chair based on also the confidence level you have with your drawing. So some chairs are very simplistic in their nature, some are a little bit harder to do. So I encourage you to find something that you do find challenging, but don't overstretch yourself and make it a completely impossible task. If you have any questions, let me know. Cats, do you have anything you would like to say in the end? Apparently my other cat doesn't want to show her face, so you only got Millhouse for today. But I believe that's all for me for today, so I will see you guys in the next one.